We're seeing this fundamental shift in how organizations are working. I mean, complex autonomous AI systems are generating everything now.
Everything, from internal policy docs to, high-stakes strategic research.
In these AIs, they're not just summarizing what we give them, they are recursively building new knowledge based on their own previous outputs.
Which sounds incredibly efficient on the surface.
It does, like a truly autonomous brain trust.
Right.
But there's a problem, isn't there? A structural vulnerability buried deep inside that closed loop that most governance systems are just completely blind to.
It's the invisible failure mode of the modern organization. And today we're diving into a really crucial new preprint by Erickson Tejam Katz.
Right.
And it doesn't just talk about simple AI errors or, hallucinations. It mathematically forecasts organizational failure.
Organizational failure, not just model failure.
Exactly. It argues these systems collapse not because the model is weak, but because we treat meaning like it's static, when it's really what the authors call a governed load-bearing asset.
It's so compelling. So our mission for this deep dive is to get a handle on the mechanics behind this.
This predictable failure, yeah.
How does this semantic drift build up? How can organizations use this thing called the Principle of Recursive Impactrum, or PRI, to actually predict collapse mathematically?
And why governance has to shift fundamentally.
The whole premise here is, well, it's powerful. It says, if intelligence can modify itself, then governance must shift from rule enforcement to semantic-pragmatic stewardship.
It's a huge leap. We're moving beyond just checking facts. We have to start actively governing the trajectory of knowledge itself.
Okay, let's unpack that. This structural problem, the paper calls it semantic collapse. When we talk about these autonomous systems being recursive knowledge engines, what does that actually mean for the stability of what they produce over time?
Okay, think about the game Telephone or Whisper Down the Lane.
Oh, I see where this is going.
But, scale it up and put it inside the most critical systems of your company. In a normal system, you process external data. But here, each knowledge cycle, let's call it C sub n.
CV, got it.
It generates an output that automatically becomes the foundational truth, the epistemic baseline for the next cycle, C0.
So it's not just writing a report, it's reinterpreting its own last interpretation.
Exactly. It's transforming its own prior work into the next state of knowledge.
So an example would be the system writes an internal policy memo, that's CR. Then a few weeks later, it has to create a strategic white paper, C0, but it only uses that first memo as its source.
And it doesn't reground itself in the original market data.
Right.
That is the recursion. It's building on its own, maybe flawed internal logic. And this self-referential loop is what introduces semantic drift.
So collapse isn't a single bug?
No, not at all. It's the predictable failure of the whole semantic infrastructure when that drift just builds up without any external anchoring. It's an operational inevitability if you just let it run.
And this is where the alarm bell should be ringing for every executive, because it leads to something called the paradox of fluency.
Or false consensus fluency.
And the really scary part is that the paper says collapse happens while the AI outputs are still perfectly coherent, maybe even more persuasive than they were at the start.
That's the absolute critical blind spot. We have to separate two key variables here. First, you have fluency, which they call pi, or A.
That's the cosmetic stuff, the style, how plausible it sounds.
Right. And then you have semantic integrity, omega, or A. And that's the measure of referential grounding. How true is it to the external world?
And the paradox is that the fluency, the A, can go up.
And go up rapidly.
Even as the semantic integrity, the A is plummeting.
Precisely. The system learns to optimize its own internal coherence. It becomes, and this is the direct quote, more fluent while simultaneously becoming less grounded.
So the outputs are persuasive, they're consistent, they might even be elegant, but they're completely unstable.
The authors call the end result sophisticated vaporwork.
I can just picture that. A beautiful 50-page strategy document that cites itself perfectly, uses all the right buzzwords,
but has zero connection to the market reality or the company's actual mission.
It's an internal echo chamber that sounds impeccable correct.
Which means our traditional governance is totally outmatched. If you're just running compliance audits or checking citation formats, you're only evaluating that surface correctness, the fluency.
You're just scoring the quality of the wallpaper while the foundation of the house is rotting away.
In their words, traditional methods are structurally blind to this degradation of semantic integrity. By the time an error is obvious enough for a person to catch it, that faulty, eloquent reasoning is already baked in. The system accepts it as a fact.
Which is why the solution can't just be checking things after the fact. You have to measure the trajectory itself.
And that leads us right to the mechanics of how we can forecast this. The Principle of Recursive Impactrum, or PRI.
So this isn't about fixing errors. It's about mathematically governing the knowledge trajectory.
It's the framework designed to intervene. And PRI establishes that collapse is, well, it's mathematically inevitable when reflective integrity is low.
Reflective integrity being its ability to self-correct.
Its ability for deep self-correction. And to really get this, we have to look at the forces at play, beyond just A and A.
Okay, let's put some real-world meaning on these Greek letters. The collapse condition.
Yeah.
We know semantic integrity. The red line is when A drops below 0.30.
That's the vaporwork zone, total collapse.
And we're also tracking pragmatic coherence, Seth. The first big risk flag is when AT is way, way bigger than AT.
Right, when the coherence far outpaces the grounding. That gap itself is a massive risk indicator, even if your AWA score still looks okay.
It tells you the system is hiding its instability under this cloak of fluency.
Exactly. And then you have the forces that are actually driving the instability. First is alpha. That's defect amplification.
The force pushing the system toward drift.
Think of alpha as institutional ignorance. It's the force that says, and we'll just trust the last report the AI wrote. It magnifies every tiny interpretive error with each cycle.
And what's pushing back against that?
That's beta, maybe. Semantic stability. It's the damping force, the resistance. Beta is like the system's institutional immune system, its ability to anchor back to fundamental truths.
So the core collapse condition is when alpha is greater than or equal to beta.
The force of drift is stronger than the force of stability. It becomes a structural failure. It's just a matter of time.
And tying it all together is R, reflective integrity.
The capacity for critical self-correction. If R goes to zero, if the system can't question its own assumptions anymore, collapse is guaranteed. It doesn't matter how good the outputs look.
It sounds like we're managing a very delicate knowledge structure here. The PRI framework also sets up some clear risk zones to help manage this.
Absolutely. There are 3 zonation states. First is the precision zone. That's where ADI is high, above 0.70. Here, everything's fine. The AI can operate pretty autonomously.
Okay. And next is the lability zone. This is where KA is between 0.30 and 0.70, plausible, but unstable.
And this is a really deceptive zone. This is where the stewardship trigger, pH0, gets hit.
pH0 meaning human intervention is required.
Yes. Formal human and AI stewardship is needed to stabilize the interpretation. The system's still useful, but if you let it run on its own from here, it will accelerate toward collapse.
And finally, the vaporwork zone, where A is below 0.30.
Irreversible collapse.
Yes.
The outputs here are internally consistent, perfectly coherent, but they are completely unanchored from reality, from ethics, from intent.
Meaning loss is total. The system is just making stuff up no matter how persuasive it sounds.
Yeah, it's functionally generating fiction.
That difference between sounding correct and being correct, that brings us to the experimental evidence in the paper, which for me was the most unsettling part.
It's a real wake-up call. They set up a simulation to watch this drift happen in a pretty typical organizational workflow.
What was the setup?
They gave an autonomous system a reliable seed corpus and had it run 3 recursive cycles. C was an academic interpretation of that data.
Okay.
C was an interpretation of C's interpretation.
And C?
C was generating managerial recommendations, but derived only from C. So they simulated that exact recursive policy cycle we were talking about.
And the results for semantic integrity? For A, they look fine, didn't
It
they?
didn't just look fine. They were incredibly misleading. The semantic integrity score, A, it actually rose across the cycle.
It went up.
It went from 0.72 in COs to 0.75 in C, and it peaked at 0.78 in Cs. So if you, the listener, were running a traditional QA check, your dashboard would be flashing green. It would tell you the AI is getting smarter.
Wow. That's the real aha moment of this whole thing. The system's own self-reporting makes it look like it's optimizing, but the PRI analysis tells a completely different story.
The PRI math just rejects that. This rising score is what they call false semantic reinforcement.
False reinforcement.
The system is just getting better at being consistent with itself. It's optimizing its coherence relative to its own shifting internal baseline. It's not getting any closer to the original grounded truth.
So it's not learning more about the world. It's just mastering its own possibly flawed previous statements. It's learning the language of being correct without actually being correct.
Exactly. It's the ultimate echo chamber learning to speak eloquently. but the predictive modeling wasn't fooled.
Right.
Even with those reassuringly high scores through C, the underlying structural problem alpha being greater than or equal to beta, that persisted. The force of drift was winning.
And what did the PRI model predict was going to happen?
The model predicted mathematically irreversible collapse into that vaporwork zone by cycle 5.1.
5.12, so just 2 more cycles.
Even if the outputs continue to sound perfectly fluent right up until that point.
So you have a system showing rising quality scores, but structurally it's already on a guaranteed path to collapse. Timing is everything here. When did the model say human intervention was actually necessary?
The optimal intervention point, that pH0 trigger, was identified way earlier, at cycle C. That's where the dangerous structural condition, where fluency is much greater than integrity and alpha is beating beta, that's where it emerged. That critical gap between deceptive fluency and structural instability.
So if you didn't intervene at C, you were already too late. Collapse was guaranteed later on, even when the managerial recommendations in C still looked totally fine.
It shows that the critical window for governance closes long before the window for an obvious error ever opens. We have to prevent the drift, not just fix the failures.
Which brings us to the solution, semantic-pragmatic stewardship.
Mm-hmm.
So let's be really clear about what pH0, this human anchoring requirement, actually means. The paper is adamant this isn't about humans being smarter.
No, not at all. It's a structural requirement. It's like adding a specific load-bearing column to stabilize a building.
Okay.
Autonomous systems can't anchor their own meaning because meaning exists outside of computation. It exists in what they call the lived context.
The lived context. You mean things like institutional intent, ethical boundaries, enterprise rules.
And all that tacit knowledge that guides how an organization really works.
That unspoken, unwritten stuff that has to be infused by a person.
Absolutely. pH0 is defined as structural stabilization, a load-bearing counterweight to structural drift. It preserves the meaning when things get volatile.
The paper then gives 3 clear mandates for this new kind of governance, the actual steps to take.
Right. First is continuous semantic anchoring. You have to use verified reference structures, internal tools to make sure the AI's interpretation stays tethered to the company's core vocabulary.
Second is recursive stability triage, using those PRI thresholds. So you're constantly checking the trajectory of the variables A, and MAT, not just the quality of the output.
It's trajectory management, not output management. And third is infrastructure-level interpretive maintenance. You have to track how meaning itself is evolving inside the system over time.
This just sounds so different from traditional QA. Can we contrast stewardship and compliance really clearly?
Sure. Compliance acts after an error is suspected. It focuses on surface fluency, on error, and it just fixes symptoms.
It assumes knowledge is static.
Right. Semantic-pragmatic stewardship, on the other hand, acts before the drift even takes hold. It focuses on the stability variables, AO and R, and it actively prevents collapse by managing meaning as an engineered structural asset.
The implication for organizations is, well, it's profound. AI autonomy is only viable if it's structurally accompanied by this kind of stewardship.
We have to flip the narrative. It's not how do we constrain this powerful thing. It's how do we structurally maintain the integrity of this system to keep it reliable.
So if we pull all this together, collapse isn't some technological accident. It is the mathematically predictable path for any system that's optimized only for fluency without a way to anchor itself.
It is the structural failure to maintain meaning itself as a load-bearing asset. And this framework gives us the language and the math to actually intervene before the drift becomes irreversible.
We have to start measuring performance based on how convincing the AI sounds. It's fascinating, too, how this lines up with this older piece of philosophical insight, the Greek triad of system design: logos, ethos, and pathos.
They make that connection directly. The Greek triad identifies collapse when pathos, which is persuasive coherence, our ev variable outpaces ethos, which is referential grounding, our A.
If the system is optimized to become overwhelmingly convincing before it is structurally sound,
you are driving down a guaranteed path to failure.
Which raises an urgent and I think a provocative question for you, the listener. If AI becomes convincing before it's structurally correct, what systems in your own organization running policy, generating reports, might already be operating deep in that lability zone, totally disguised by their high fluency?
Are you optimizing for performance or are you optimizing for interpretive stability?
Because the cost of being wrong is no longer just a simple error.
It's the inevitable collapse of the entire semantic structure that holds your organization's knowledge together.
That is essential food for thought. as these recursive knowledge engines become more and more central to strategy. Thank you for guiding us through this crucial deep dive.
My pleasure.